Okay, 2.3 is postulates and diagrams. So a postulate is a rule that is accepted without proof. Okay, so basically we have just decided that these are true things. We don't have to be explained or given a reason why at this point. Okay, so we have this list of postulates. Okay, so I'm going to read through them and then I'm going to show you the example of them on the other side. Okay, excuse me. So postulate 2.1 is the 2-point postulate, which says that through any 2 points there exists exactly one line. 2.2 line point postulate is a line contains at least 2 points. So now the example of these two postulates are written over here. So basically the first sentence is going to go with 2.1 and the second sentence is going to go with 2.2. So it says through points A and B there is exactly one line L. Okay, line L contains at least 2 points, and I'm going to add something in here. I want you to change this to a comma, and then I want you to name the points that are on that line. So then it would be points A and B. Okay. 2.3 postulate is the line intersection postulate. It says if two lines intersect, then their intersection is exactly 1 point. Okay, so over here we have the example is the intersection of line M and line N is point C. Okay, 2.4 and 2.5. 2.4 is the 3-point postulate, and it says through any 3 non-collinear points, there exists exactly one plane. 2.5, the plane point postulate says that a plane contains at least 3 non-collinear points. So over here to the right, we have through points D, E, and F, there is exactly one plane, plane R, and that goes with 2.4. Okay, and then plane R contains at least 3 non-collinear points, and again, I'm going to make you make that a comma, and then put points D, E, and F. Okay, and that one would go with 2.5. Okay, 2.6 is the plane line postulate. It says if 2 points lie in a plane, then the line containing them lies in the plane. Points D and E lie in plane R, so line DE lies in plane R. Okay, and you can see this all in these pictures right here. Okay, and the last one is the 2.7 plane intersection postulate. If 2 planes intersect, then their intersection is a line. The intersection of plane S and plane T is line L. Okay. All right, so example 1 says state the postulate is illustrated by the diagram. So basically this is showing me that if 2 lines are crossing, then they intersect at 1 point. Okay, so this would be the line intersection postulate. And you could call that that would be 2.3. Okay, and it says that if 2 lines intersect, then their intersection is exactly 1 point. Okay, and then part B, I see that 2 planes are crossing, and then I see that they have this one line here. So that would be 2.7, the plane intersection postulate that says if 2 planes intersect, then their intersection is exactly 1 line. Okay, all right, let's turn the page. Okay, so it says use the diagram to write an example of the postulate. Okay, so what I want you to do here, okay, you need to use basically this right-hand side, those sentences should be the exact same sentences you used on this example. The only difference is what you're naming the points and what you're naming the lines or planes based on what is shown in the picture. Okay, so keeping that in mind, I have that off to my side that I'm going to use to help me write them. Okay, the 2-point postulate. Okay, it tells me 2.1. So I'm going to do that first sentence. So it says through points. Okay, so I need 2 points on a line, basically. So I'll say G and D. There is exactly one line L is what they call it. Okay, or you could say GD with the line above it with 2 arrows, whatever. Okay. All right, 2.2 is line L contains at least 2 points, comma, points G and D. Okay, keep going down the line. 2.3, the intersection of line L and I'm going to call the other one CD is point D. Okay, the next one is the 3-point postulate. It says through points. Okay, and remember these cannot be all collinear, so I need one that is not on the same line. So I'm just going to make it easy and do C, B, and G. There is exactly one plane, comma, plane, they call it M, or remember you can do capital C, B, G all squished together. Okay, either one would be fine. Keep going down the line here, then 2.5, okay, plane M contains at least 3 non-collinear points, comma, points C, B, and G. Okay, make sure you are writing the exact same sentences that they have here or it will not be correct. Okay, 2.6 is the plane line postulate. Okay, so I see that points, we'll do C and D, lie in plane M, so line CD lies in plane M. Okay, and the last one is the plane intersection postulate. This diagram only has one plane, so in this case you would just write not possible. Okay, if it had 2 planes, then you would continue in writing that example. Okay, example 3 then is sketching a diagram. Okay, it says sketch a diagram showing line TV intersecting segment PQ at point W so that segment TW is congruent to segment WB. Okay, so we have a line TV intersecting PQ. So we have a segment PQ, and I have a line what is this line? Sorry, TV. Okay, TV, and it intersects at point W. And I drew it such that these are, which you do have to mark them to show, okay, that they are congruent. Okay, and that works. Okay, that could look kind of a lot of different ways depending on which direction you drew things, but this works. Okay. Okay, the next part is talking about a line perpendicular to a plane. Okay, so the picture here, okay, if you have a line, oops, that wasn't a very good plane, but you get the idea, that I have this plane and I have this line that is not on the plane. It is going through the plane. Okay, in order for it to be perpendicular, you have to see this box. Okay, and you might see it also running along with this line. Okay, how you know that it is not perpendicular is if you have a plane and you do not see that box. Okay, you have to see that box there in order for it to be true. Okay, turn the page there then. Okay, example 4, interpreting a diagram. It says, which of the following statements cannot be assumed from the diagram? Okay, so points A, B, and F are collinear. So A, B, and F are all on the same line. So that one is true. Okay, so I'm just going to write a little T out here next to it. E, B, and D are collinear. E, B, D, that would be no. Okay, so that one cannot be assumed. So that's one of my answers. Line AB is perpendicular to plane S. So AB is perpendicular to S would be true. Line CD is perpendicular to plane T. That one I do not know because there's not a 90-degree angle there. Okay, so that one would be one of the ones I cannot assume. Okay, and segment AF, or sorry, segment AF, line AF, so AF right here, intersects line BC at point B. That one is true as well. Okay, so there's just those two that you cannot determine. Okay, so in the exercises, use the diagram to determine whether you can assume the statement or not. Plane L and K intersect at line PS. That one is true. Okay, angle QOP is a right angle. QOP, you see that box down there, so that one is also true. And line PS and MQ intersect at point O, that one is also true. Okay, just so happened that all of those came out to be true. Okay, your friend claims that if 3 lines intersect each other, then there are 2 points of intersection because of the line intersection postulate 2.3. Is your friend correct? Explain your reasoning. Okay, so if I have 3 lines intersecting each other, okay, they could intersect each other like this. They could intersect each other like this. Or, yeah, that's the only 2 ways that I have. Okay, so that one would be no. They could cross at 1 or 3 points instead. Okay, and that's all you need for 2.3.